Now we are going to explain the second protection function, which is over voltage. Again, I highlighted this in the same we have at the same time basically over current, which is this one, over voltage. So this relay, digital relays can have multiple functions. In the old time, when there was mechanical relays, every relay could protect it against only one parameter. But right now, these digital relays are like supercomputer. They can have many different protection functions. So this is the over voltage. Here, let's go to here in the scaling. As you can see, it was primary was 20,000 and the secondary is 25. This is the minimum voltage that we can apply. We can apply maximum is 250, minimum is 25. But I always recommend to work with the 25. This is a low voltage because the tester will give you, if you put 250, the tester will give you 250 volts and it is dangerous. 25 is the minimum and it is safe for yourself and for everybody that's around. So this we have to, for the safety in the lab, we have to always put 25. So it means if we have 20,000 in the transmission lines, we will have 25 volts in here. Let's say this is our unit, 20,000. So if we put 0.5 per unit, it will be 10,000. Let's go to the protection function here. Right now it is 1.2. It was 20,000 or 2,000. Scaling for that, it was 20,000 for primary, and if it is 25, it will be yes. So we go to the protection function. So 25 meant 20,000. 1.2 if we put, it means 2,400. Like a pickup value for the voltage. If you put 1.2, every unit of the 25 was 20,000. 1.2, if we put here in pickup value, it will give you 24,000. Yeah, it was per unit. 20. Segasin, mida tehes. Kas uuesti ütlen? Okay, yeah. So here, yeah, 1.2 is 24,000 volts basically. So from here we will, and the delay, we have this direct time. I think it was direct time. So we are deciding that operating curve will be direct timing, operating delay 3 seconds. You can see here reset delay is 1, and the hysteresis. This we can read in the manual what they are meaning. We will, in the theory part, we will learn about them. But right now we have this 3 second operation delay. These are a lot of very long. We usually don't use this 3 seconds. We use in the milliseconds, like 50 millisecond, 100 millisecond, not like 3 seconds. But right now I just want you to see when the current reaches to the the pickup value, then it starts measuring the time, and then disconnects. So this is our settings. It's loaded there, and on our tester, so I have to one of the voltages I will give 1.2 value. 1.2 is like 27 volts I should give, I think. Let's go. So here for the current I will give 0, because we don't need current. I don't want the tester to give at the same time different types of the. So I clicked on the amp IA, I made it 0. I will go to the voltage UA, for example. I will put 25, which is the normal value. With 25, it should not like disconnect. For like voltage 2, we can give different numbers. For example, for this I will give 12 amperes, and for the third one I can give also 20. So these are the voltages that I am applying to the relay UABC. Let me start, and then you can see here the numbers will appear. Start. Yeah, the voltage that, okay, it's disconnected already. So which one was 20? What was our setting? Let's release it. For when I started, let's start again. Okay, I will make them a smaller number. Like I will make them smaller number for now, and then start increasing them to see in which level they will, like 2 amperes, 2 volts. And here I can select that I want to increase voltage UA. The voltage, I want to increase it by 1 every time that I am pressing, and then let's start that. Yes. Right now I have 2 amperes here. I just want to see 1560 volts there. Let's increase it. Right now I have 4000, 7, 8, 9, 10, 8000, 14 doesn't apply. It's 17, 13,000 volts, 21. Yeah, it is not activating right now. 25 is okay. Yeah, it's not activating. If I reach up to 30, I think at 30 it should start. 29, yeah, with 29 is okay. 23,000 is okay. And 30, now it should count the 3 seconds. If I go over that, yes, that's how it worked. Now let's see what was the trip value. The trip value was 3 seconds and 0.02020 seconds. 3.02020 seconds. 22 milliseconds was late. I don't know why it tripped before, because it was not supposed to trip. And you can see that the circuit breaker 1, the Wimsus-Lulity, the circuit breaker is connected to that. So here the LEDs are like showing which error. The LEDs also we can do in the program. Right now we are not going deep there. Later we will study those. Now I will release this, and first I will release it, and then I have to, these are the operation buttons, like control buttons. I resetted the system. Now it is back to here. So that's all how we can control how we can use the tester, how we like follow the result of our program, the trip time. This is basically the most important parameter that in the power lines we need to make the relays coordinate together so that we can have the maximum speed and the maximum selectivity for like disconnecting different parts, different zones, using multiple relays that have to work together in the network.